To walk you through solving one-step equations today. So if you have your notes out, hopefully you can title this section Solving One-Step Equations. Now, while we're working through these equations today, a lot of them are going to be relatively simple, okay? And most of them you might even be able to solve in your head without really doing any work. Getting the right answer, though, is not going to be the most important thing today and in this unit. We really want to make sure that you're learning the process and the foundation of equation solving so that when these equations become more complex and more complicated, you will still be able to solve them. So equations that we're going to be solving today are going to look like x plus 4 is equal to 9. Now, if I were to ask you, what's the missing number? X, when we add 4, we get 9. I'm sure that many of you would just intuitively know that x is going to have to be 5, right? But here are the equations that we are heading towards. Equations like negative 3x minus 4 all divided by 5 plus 12 is equal to negative 7, okay? If you can still look at this thing and just say, oh, I know what x is, then you don't need to learn this process. My guess is everybody is going to need to learn this process. I would not know what x is out of that equation. Please do me a favor. Do not hit pause and do not try and solve this thing. It is not going to be pretty. So don't do that, but that's where we're headed, okay? So when I say that the work is more important, it's because I want you to be able to solve those when we get to them. And if you don't learn this process now, it's going to be that much harder when you get to the more complex equations, okay? So how do we solve a one-step equation algebraically? Well, we've already kind of been doing it. When you did those build and then your undo or your solve tables, what you were really doing was solving an equation. You were thinking about your variable, your input, and then these next steps were what was happening to x, and then you got your output. Right? We went down the page this way, and then to solve it, we did the opposite operations, right? The inverse operation, and we followed that steps back until we knew what x was equal to. So that's what we're going to do. We just don't want to take the time to fill this table out over and over and over again. So we're going to do the table more in our heads, and we're going to learn how to show this work on our equations. Okay? So what I always do when I'm starting with equation solving is I say, think of this equation like a balance. It has a left side and a right side. And our job as mathematicians is to keep those two sides balanced with each other. So if I make some change to one side, I need to make the same change on the other side. If you and a friend or a sibling both had the same amount of money, if you both had $10, and I wanted you both to keep that same amount of money, if I give one of you $5, what do I have to give to the other person so that you still have the same amount? I have to give both of you 5, right? If I took $7 away from one of you, I'd have to take 7 away from the other as well. So that's what we're going to be doing when we solve equations. Start over here on the left side. We start with our variable, starting with our input, and then we ask ourselves, what is happening to that variable? In my building steps, I would start with my input x, and then I would say I'm adding 4. If I'm adding 4, what is the inverse operation to undo that addition? To get rid of a positive 4, I need to subtract 4. If I subtract 4 from that side, from the left, I'm also going to need to subtract 4 from the right. This one in red comes from needing to keep these equations balanced, okay? The two sides of my equation. All right, so what happens now to our equations? These 4s, a positive 4 and a negative 4, that becomes a big 0, right? And that goes away from the left side of my equation. So all that's left on the left side is x. In the center, we have an equal sign. X is equal to 9 minus 4, which is 5. So that is our answer. Our equation is solved. X is equal to 5. Whenever we are solving equations, it's always good to go back and check our work. Let me get rid of these real quick. Once we think we know what x is, we can say if x is 5, then, and we go back to our original equation, x plus 4 is equal to 9, and then we'll substitute that value for x. 5 plus 4 is equal to 9, and then just do this math, 5 plus 4, 9 is equal to 9, and so we know that our answer is correct. If you made some math mistake somewhere and you got 8 is equal to 9, you know that that's not true, and you know you need to go back and check your work. All right, I'm going to let you hit pause here and record anything that you need to record in your notes, and then we're going to do one more example. All right, hopefully you have all of that down. Example number 2, we are going to do a subtraction equation. Y minus 7 is equal to negative 4. So same thinking as that last question, last problem that we did. We have a left side and a right side. I need to get my variable by itself, so I need to think about what is currently happening to it. In this equation, we are subtracting 7. So to undo a subtraction, I'm going to need to add. That's that inverse operation step. As soon as I add 7 to the left side, what do I need to do to the right side? The same exact thing. Add 7, add 7. When we do that, on the left side, we're just left with a y, because these cancel each other out. And y is equal to negative 4 plus 7, which is a positive 3. So y equals 3 would be my solution. If y equals 3, then my equation would become 3 minus 7 equals negative 4. 3 minus 7 is negative 4, and negative 4 equals negative 4, so we know we're good. All right, you are going to have a chance to practice a couple of these problems on your own, and then we will come back and we will look at one-step equations involving multiplying and dividing. Good luck.